Hey, welcome to Aeroguy. And this is another problem that we are trying to solve, and this is all about indicated horsepower. For this example or problem, it's asking for us to compute for the indicated horsepower for a six-cylinder engine that has a bore of 5 inches, a stroke of 5 inches, and it is turning currently at 2,750 revolutions per minute with a measured indicated mean effective pressure of 125 psi per cylinder. Now, right before we go diving into the problem itself, I'd like to define for us to solidify our foundation. What is indicated horsepower? Indicated horsepower is the theoretical power produced by the engine calculated inside or calculated from the pressure inside the engine's cylinder before accounting for any mechanical losses. Therefore, I'd like to emphasize this one. This is pure power inside the cylinder, right before the power is transferred to the crankshaft and to the other parts of the engine. Okay, so since IHP is just indicated horsepower is just power in its basic sense, power or P is just work per time, right? What is work inside the cylinder? Work is computed by the pressure, the average pressure inside the cylinder, and the volume that is being displaced during the power stroke. Okay, it's basically the moment the piston is at top dead center at power stroke until it reaches almost bottom dead center, the entire volume that was being displaced. Okay, so in that case, this is just pressure in the cylinder times the volume in the cylinder divided by time. Okay, now what is this volume here? This volume here is just area times the length per time, right? And remember, we are computing for the indicated horsepower. So we are computing this power during the power stroke. Okay, and currently the engine is turning at 2,750 RPM. The question is how many power stroke is happening per time. Remember that for every for the completion of the four strokes, you have to have two crankshaft, two complete crankshaft revolution. Okay, remember the power stroke happens it happens once every two crankshaft revolution. Okay, so that is why in computing for the indicated horsepower, you also need to consider how many power strokes is currently happening. And that can be computed by the number of revolutions, the number of crankshaft revolutions divided by 2. So that's going to be RPM divided by 2. Okay, and that is represented by N, the number of power strokes. And you also need to consider how many cylinders does the engine have. So that's going to be represented by K. Okay, and for easier memorization, we represent power, or the indicated power, as, or we rearrange the terms P, L, A, and K, or the factors, divided by time. Remember, we are trying to compute for the indicated horsepower. And to compute for the indicated horsepower, you have to convert your power output, as you have computed, into horsepower terms. Okay, so just let me erase this. Okay, remember, 1 horsepower is just equal to 33,000 pound-feet per minute. Okay, that is why if you break down the units for IHP, it's just then going to be equal to PLANK over 33,000 lb feet per minute. This is just the uh, shortcut formula. But if you break down the units, it's going to be PSI, pounds per square inch, length in terms of feet, area is in terms of inches squared. You don't have to convert that, as this will cancel out. Okay, so we also have N, which is the representative of the number of power strokes per minute. So that's just going to be your number of cycles per time. It's going to be in minute. And the number of cylinders, which does not have a unit. You also have the conversion here. That's going to be lb feet, and it has a time factor being divided, so we put it up. So when you cancel out the units, all the units will cancel out, and then you have the horsepower. Okay, so solving for the problem, since we have the solution here, or we have the formula here. Let me just erase this. Pressure is indicated as, or is given as 125 psi IMEP. So that's just going to be 125. Not going to include the units now since we already did our dimensional analysis. Okay, that's 125 in form of psi. Length is given as the stroke of 5 inches. Remember, During our dimensional analysis, we have to convert this into feet. Okay? And A is given as the area of the piston or the bore of the piston, which is given as, since it is a assumed as a circle at operating temperatures, so the area is given as pi d squared. D is the diameter, which is the bore. So that's going to be 5 squared, pi d squared over 4 multiplied by 2,750 divided by 2 times the number of cylinders. U divided by 33,000. This will give you of a value of IHP is now at a value of 8,421 270 divided by, so it's not 8,000, 8,421,270 divided by 33,000 equal to 255.19. That's the final answer. In, don't forget, in horsepower. Okay, that's it.